Hi, this is Mrs. Boykin, and I'm discussing solving radical equations. First of all, there's some basic rules that I want to talk about, and they are listed here for you to refer to. We're going to isolate one of the radicals. Maybe there's more than one radical, but basically we want to go through the process of getting one radical on one side of the equation and everything else moved to the other side. If there are two radicals, then we're going to try to get one on each side of the equal sign. The second step is to get rid of your radical sign. We're going to use the exponent that is the same as our index. And so what I mean by that is if we have something such as the square root of, let's say, x minus 2, to remove the square root, the index is technically 2, but we don't write that. To remove that, what we're going to do is we're going to square the square root. So what that does is cancel the square root symbol, and you're left with x minus 2. Similarly, if you have a problem such as the cube root of x minus 4, to get rid of the cube root, we would simply cube this portion of the problem, and it would cancel out, and you would be left with x minus 4. If you still have a radical left, you're going to repeat steps 1 and 2. Most of our problems, we're not going to have a radical left, but we're going to then solve the remaining equation. Quite oftenly, it's a linear equation that might be left, such as x minus 5 equals 10, and we're going to solve for x. But sometimes we might have a situation where we're left with x squared equals x plus 2. And we're going to want to move these to the opposite side of the equation because we know in solving quadratics, they must be equal to 0. They must be equal to 0 in order to solve them. We're going to solve those either by factoring, graphing and looking for the x-intercepts, and sometimes as necessary we might need to use the quadratic formula. Check for extraneous solutions. Extraneous solutions are solutions that we get in our algebra is perfectly fine. However, when we substitute the value into the original equation in place of the variable, they're not going to produce a true statement. We can also do this by graphing our solution, and I'm going to do a separate video on graphing radical equations. So let's begin with our first problem. Let's erase this. Sorry about that. I re-recorded and forgot to erase. Alright, our first problem is a square root of v minus 3 equals 5. So as I mentioned in my instructions, we have v minus 3 equals 5, and we're going to square each side to get rid of our radical. And what you do to one side, don't forget you do to the other. So squaring the square root cancels it out, and we get what's underneath the radical symbol, and 5 squared is 25. We now have an Algebra 1 type problem that's easily solved. We add 3 to both sides, and we get v equals 28. That's what we think the answer is, but we need to check that. So we're going to put that into the original equation. So I'm going to use a different color. V is 28. And we're going to subtract 3 and see if that equals 5. So 28 minus 3 is 25. And of course the square root of 25 is 5. And so this ends up being a true statement. So I know that my solution, v equals 28, is a valid solution. Let's take a look at our next problem. Okay, in order to get rid of the square root, again, I'm going to square it, and what I do to one side, I do to the other. 1 squared is 1 equals a divided by 3. Now let's go ahead and solve. To get rid of the denominator, I'm going to multiply both sides by 3. The 3's cancel on the diagonal, and we end up with a equals 3. And to check our solution, again, we need to put that back into the original problem. So 1 equals the square root of 3 divided by 3. 3 divided by 3 is 1. And if we put in the calculator, square root of 1 equals 1. So we also have a true answer, and we know this is correct. Let's take a look at the next page. Oh, gotta erase that one too. Was having trouble with my slate today. Alright, so we have radicals on both sides of the equation now. So we're gonna square one side, and what we do to one side, we do the other. Canceling out the radicals, I get 19 minus 2x equals 2x minus 5. Again, this is an Algebra 1 problem. I like to work with the variable term and eliminate that first. So I'm going to add 2x to both sides because I like my coefficient to be positive. And I get 19, this cancels out, equals 4x minus 5. Let's go ahead and add 5 to both sides. And we get 24 equals 4x, dividing by 4 to solve, x equals 6. Okay, time to check. So we have the square root of 19 minus 2x. I'll put that in there in just a sec. 2x minus 5. And so my solution was 6. I'm going to plug it in place of x. 19 minus 12 equals the square root of 12 minus 5. 19 minus 12 is 7, and 12 minus 5 is also 7. So we get the square root of 7 is equal to the square root of 7. That's a true statement. So we know this solution is valid. Wow, that's a busy slate screen. There we go. All right, so on this one here, we have to start out by squaring both sides to get rid of the radical, and I end up with x squared equals 12 minus x. Now at this point, you're seeing that this is a quadratic, so we solve quadratics by setting the equation up equal to 0. So that means we're going to add x and subtract 12. And what we do to one side, we're going to do to the other. None of these are like terms, so let's bring it down in the proper order. The x squared comes first, x comes next, integers at the end, and 12 minus 12 is 0, 0, and there is my quadratic. So at this point, we either graph to find our solutions, our x-intercepts, our roots, our zeros, or we can do factoring, which is really probably the first thing that you want to do. It doesn't hurt to graph it though, because that helps us as well, making sure that there is indeed real roots, real solutions, and not imaginary. And a little review of factoring, we multiply the first term times the last term, a times c, field goal as we call it. So 1 times a negative 12 is a negative 12. And the center term is a positive 1. So we need to ask ourselves, what are the factors that are going to multiply and give us a negative 12 but add up to a positive 1? And that's going to be a positive 4 and a negative 3. So we write down the first term, we write down our last term, and our middle terms are 4x, don't forget the variable, minus 3x. So here it is. And then this is the part where we start grouping our first two and our last two, and determining what we can divide each by. So we're dividing by x, and we get x plus 4. Here we have a negative number as our first term, so we know we have to divide by a negative, and 3 and 12 can both be divided by 3, specifically negative 3. And let me go ahead and put this in a different color like I typically do when we're in class. Okay, pulling out that negative 3, and what's left is Negative 3 divided by 3 leaves us with x, and negative make a positive 4. So we can see that those binomials match. So bringing it together for my final answer, I get x minus 3 times x plus 4. Don't forget, this all equals to 0. This is the part where we solve. We factored, now we solved. So we have x minus 3 equals 0. And we have our x plus 4 equals 0. We could pretty much tell what those solutions are by looking at it. There's your algebra in case you need help with that. So my first solution is x equals 3. My second solution is going to be x minus 4. So x equals a negative 4. Now we need to check both of those solutions to see if we have both of them valid, one's extraneous. So this is the important part. So taking a look at our problem, we have x equals the square root of 12 minus x. So let's first test the positive 3. I'm going to plug in that positive 3. And, have to plug it in both places. Alright, so here we go. 3 equals 12 minus 3 is 9. And the square root of 9 is indeed 3. That's true. So I know that this is a valid solution. Let's go ahead and check that negative 4. Put it in black. Oops, wrong part. Let's erase this. And see if we have, I'm running out of room, guys. Okay, so now we're going to check the negative 4. And so now we have 12 minus a negative 4. That's like saying 12 plus 4. That's 16. And the square root of 16 is 4. That does not equal negative 4. So this is false. In other words, this is an extraneous solution. We cannot use it in our answer. So there's your answer, x equals 3, with an extraneous solution. As you can tell, I worked out these problems and did one recording, fumbled it, had to do it again. All right, here we go. Here's another problem, a little different. We have the cube root of 4x minus 1 plus 2 equals 5. So we have to start out by isolating the radical. That's what I mentioned in those directions. We're going to start by subtracting 2 from both sides, and we end up with the cube root of 4x minus 1 equals 3. Now we need to cube each side. Cube root, so we have to cube it. What you do to one side, you have to do the other. So the cubing, raising to the third power, cancels out my radical, and I'm left with 4x minus 1, and 3 raised to the third power, use your calculator, is 27. We can now solve. Add 1. And divide by 4. X equals 7. Okay, let's check our answer. Be very careful to make sure that this is separated. Alright, so let's work it out. 4, this is the cube root. Cube root of 28 minus 1 plus 2 equals 5. And the cube root, 28 minus 1 is 27. And the cube root of 27, use your calculator, is 3 plus 2 equals 5, and we see that it does check, confirming that x equals 7 is a valid solution. Well, I hope the video on solving radical equations helps you. I hope you watch this before class so that we can get right to practicing problems. Hope you have a great night.